Chapter 2 is about geometric shapes and measurement. So strategy, each chapter has a strategy at the beginning that they talk about on the first page or two. The strategy for this chapter is look for a formula. Because of time today, I'm not going to spend time going through that example. We've done some problems where we've had to use formulas, so it's just saying when you have a problem, if you can apply a formula that you know to it, then do that. The section we're going to cover today is 2.1. It covers undefined terms, definitions, postulates, segments, and angles. Objectives: define terms of geometry, measure angles using a protractor, and use special angle relationships to determine angle measures. So this is just a lot of background to the course. These are definitions you need to know and skills you need to know, measuring skills and that type of thing. So this is stuff that we will build upon. But it's important that you learn these terms so you know what we're talking about as we move through the course. First definition, axiomatic system. An axiomatic system begins with a small set of undefined terms and builds through the addition of definitions and postulates to the point where mathematical theorems can be proved. Postulates are rules that are not proven. Theorems are rules that are proved using postulates. When they first started geometry, there were no rules existed and no terms existed. So they had to make some up and build off of those, and they were just consistent with the use of their postulates to create. We are studying Euclidean geometry. Euclid, this geometry started back in ancient Greece by a guy named Euclid. And we still use it today based on the postulates he made. He had, I think, 26 or 27 postulates that he built geometry on. And the postulates aren't proven. They're just ideas that he made, that he built the system of geometry we use today in Euclidean geometry on. And then he had 3 undefined terms in geometry that he built all the postulates on. Anybody know what those 3 undefined terms are in geometry? Okay, they'd be point, line, and plane. A point is the basic unit of geometry. It has no size, is infinitely small, and only has location. So if I take a place in space, this point right here, I take my fingers away, that's a point. It's got a location, but it doesn't have any size. All right? It's just a location in space, a single location. It's named with a capital letter. So it's going to look like this. You've got your point, and you're going to put a capital letter next to it. Point A. All right, any questions there? Okay. The second undefined term is line. Definition of a line is a straight arrangement of points. A line extends forever in both directions. So there are an infinite number infinitely many points in a line. Infinitely many points in a line. It has infinite length but no thickness and extends forever in two directions. A point is named using 2 points on the line. So here's how we show a line. Okay, a line has arrows on the end. If it doesn't have arrows on the end, then it's just a segment, a line segment. Most of the time, that's what you think of when you think of line. You think of a line segment, but a line actually continues on in both directions, so we put arrows at the end. So I could call this AB or BA with, but it has to have a arrow, a line symbol above it with arrows. If you just put a line segment, if you just put a dash like that, that means it's a line segment. That's not right. It has to have arrows on it. All these little details are things you need to do correctly, or it'll cause you to have deductions, even though you know what you're talking about. If you don't label them correctly, then it won't be right.
Delivering your quizzes. Best of luck.
I could also call this line AB if you don't put the symbol above it, or line BA. That's not done very often. Usually it's just the letters with the line symbol over it. The third undefined term is plane. Nope. Third undefined is plane. A plane has length and width, but no thickness. Can somebody give me an example of a plane in this room? Or part of a plane. A plane, it says here, it's a flat surface that extends forever. Well, in this room there's nothing that extends forever because we have boundaries, but what would part of a plane be in this room? Nina? The floor. The carpet on the floor. Yeah, it's a flat surface, extends in all directions. Give me another example, Shatice.
That one?
Oh, the picture up there?
No, all the way over there.
The what?
Like the one that says hot jobs. That one, that extends forever and it's flat.
I don't know what you're talking about.
Right here by the Alabama.
Oh, hot jobs.
Oh, yeah. That's an example. Yep. That poster is an example. Any other examples? Okay, your desktop is a plane. The chalkboard is a plane. All those things. Okay, anything that's a flat surface that extends is a plane. All right, so we name a plane by using 3 points in a plane or a capital cursive letter. So it looks like it can look like this. We have 3 points C, D, and E. and we call that plane. C, D, and E, right? And then we have, or we could, it may have a cursive letter, a single cursive letter, and we would call it plane P, right? So if there's a cursive letter, you'll just use one letter. If there's standard letters, you have to use 3. All right, and you do need to write plane in front of it because CDE, angles have 3 letters, planes have 3 letters, and that type of thing. So you don't want to get that confused. So write the word plane and then the letter after it, or letters. Any questions on the undefined terms? Space. It's the set of all points. The set of all points is space. Infinitely many points in space. Postulates. We talked some about this already. Postulates are statements that we assume to be true. Euclid, they established some first principles on which geometry is based, and Euclid, as I mentioned before, an ancient Greek mathematician, established geometry's first postulates. Theorems, results that we deduce from undefined terms, definitions, or postulates, and the results that follow from them. Again, a theorem is something that can be proven. A postulate's not proven, a theorem is proven. Our first postulate: every line contains 2 distinct points. At least 2 distinct points make a line. Now, these postulates, you don't have to memorize that this particular postulate is 2.1. The numbers, you don't have to know what number the postulate, but you need to know the idea. Okay? You don't have to memorize the definition word for word, but you need to understand and know the idea that every line has at least 2 points. Let's draw a picture to exemplify this. We've got 2 points, A and B. There's a line with A and B that goes through both points. We would name this AB with a line symbol over it, or BA with a line symbol over it. The next postulate says that 2 points are contained in one and only one line. Again, I draw A and B. I draw a line through them. The only other way I could draw through A and B is to do something like this, and that's not a line. Only the original line is the line that goes through the 2 points. If 2 points are in a plane, then the line containing these points is also in the plane. So line EB is in that plane. The plane contains the points A and B, so the line AB is also in the plane. Points are said to be collinear if there is a line containing all of the points. In this picture, A, B, and C are collinear. A, B, C, and D are not collinear because D is not on that line. Non-collinear means there is no line that contains all the points. In the picture above, A, B, and D, you could say are non-collinear. Three non-collinear points are contained in one and only one plane. So 2 points make a line, 3 points make a plane. And every plane contains at least 3 non-collinear points. Points are called coplanar if there is a plane containing all of the points. If a group of points are all in the same plane, they're coplanar. In space, there exists at least four points that are not all coplanar. A picture of that would be like this. If we had points A, B, and C, 3 points make a plane. All A, B, and C are coplanar. But then there's going to be a point D somewhere off that plane that is not coplanar with A, B, and C. There's always going to be that point D. Coordinate. A coordinate is a real number associated with a point on the line. So, A is the coordinate for -1 on this line. Now you're probably used to, from algebra, the coordinate plane where you have two numbers that represent where a point is. It's going to have two numbers, but you still give it a letter for that place in space in the plane. Line segment. A line segment consists of two points called endpoints. Of the segment and all of the points between them that are collinear with the 2 points. So here is a line segment, AB. That is not a line. That is a line segment. So in this course, when you see that, don't call it a line. You think of that as a line, but it's a line segment. Okay? A line segment is what this is going to be in this course. It's got endpoints. We name the line segment AB or BA with a dash over the top. That dash represents a segment. It is used to name a line segment containing those 2 points. AB without a dash over it, or the M, which stands for measure. The measure of segment AB is a length. It means the length of or distance from A to B. It's going to be a number. If you have just AB, we don't use MAB very much, but if you have AB with no symbol over it, that is a number. Two segments are said to be congruent if they have the same length. So in this picture, we've got AB and CD. These segments have the same length, so we can mark them each with a tick mark. That shows that they're the same length, same number of tick marks. Could put 2. You could mark them with 2 tick marks. As long as they have the same number of tick marks, it means they're the same length. So we could say AB is equal to CD, or we could say AB with a line symbol over it is congruent to CD. That equal sign with the squiggly over it means congruent. A ray is a portion of a line that has one endpoint and extends infinitely in one direction. This is a picture of a ray. The order of the letters matters in a ray. I have to have the endpoint first in a ray. Ray AB is not the same as ray BA. Ray BA would be going this direction. Okay? So ray A, I would name this ray AB and put a line with an arrow on one end. That symbolizes ray. Angle. An angle is two line segments or rays meeting at a common endpoint. The endpoint is called the vertex of the angle, and the lines and the segments or rays are called the sides of the angle. Here's an example of what an angle looks like. This one's formed by rays. Okay, I would name this angle ABC, or since there's only one possible angle at this angle, then I could call it, you can call it with just its vertex, B. Now, very important when naming your angles, because this will cause you difficulty later on if you don't get this right now. When you name an angle with 3 letters, the vertex has to be the middle letter. Angle CAB is not the same as this angle. Okay, it would have a vertex of A. So the middle letter is the vertex. An example of why you can't just, if you have an angle like this, a picture like this, it's got this other line. Now I cannot call this angle B because there's 3 possibilities for angle B. We could say it's this angle, we could say it's this angle, or it's that angle. So I would have to name each one of those angles with 3 letters so I know which one I'm talking about. Let's take let's label the angle. Okay, this is angle DEF. So this is a vertex. And these are sides. All right, any questions? Okay. Name all the angles using 3 letters in this picture. Which angles can be used using only 1 letter? So using 3 letters. Someone give me an angle in this picture. Go ahead.
TAH.
Angle TAH. Give me another one.
MAT.
Yeah, angle MAT. Give me another one. Yes, Nina.
Angle TAM.
TAM and MAT are the same thing.
Oh, okay.
Yes, right here.
Angle M.
Okay, let's name it first with 3 letters. Name it with 3 letters.
NHA.
Nope, you have to have the vertex in the middle. Go ahead. AMH. Angle AMH. Right? Give me another angle. There's one more. Yes? MHA. That's we did AMH. MHA and AMH are the same thing. It's just reversing the letters. There's one more. Yes. Yes, AHM. Angle AHM. Now, which 2 of these can I name with 1 letter? I can this one and this one, right? There's no other possible angles there. So we could have this could be called angle M, and this could be called angle H. At A, with A of the vertex, there's 2 possible angles, so I can't name these other upper ones with one letter. All right, any questions there? Okay. Degree is the next term. A degree is a unit of measurement we will use to measure an angle. Just like inches measures the length, a degree measures an angle. A ray revolves completely around its endpoint makes an angle measuring what? If we take a ray, here's the ray, we revolve it completely around the end point. How many degrees is that? 360. Yes. That's 360 degrees. So here we have the, this would read 32 degrees. The little circle symbol is a symbol for degrees. And then you can break degrees down further into minutes and seconds. The number with one slash behind it is 15 minutes. And then we would say this is 40 and 40 seconds. One degree is equal to 60 minutes. So when I get up to 60 for my minutes on a measurement, I'm going to add 1 to degrees and then have 0 minutes. Right? It's just like time with hours and minutes and hours and so on. So it's one degree is 60 minutes. 1 minute is equal to 60 seconds. All right? Is that clear? Everybody understand what I'm talking about with that? Okay. All right. A protractor is used to measure angles. I'm going to pass those out to you. I spelled that wrong. Let me rewrite that. I will pass out your protractor and other tools while you're taking the quiz today. So a protractor is used to measure angles. We're going to skip the... how many people think they know how to measure an angle with a protractor? Raise your hand. Okay. We can, when we go over the homework, if you have a question on that, we'll cover it. But because of time, I want you to have adequate time to take the quiz. We're going to skip this example of measuring with a protractor. I will tell you, if you want to go back and check see if you can do it right, angle ABC is equal to 24 degrees, and angle EBD is equal to 116 degrees. Type of angle measure. An acute angle is between 0 degrees and 90 degrees. A right angle is 90 degrees. An obtuse angle is between 90 and 180. A straight angle is 180, that's a line. And a reflex angle, we won't use reflex angles in here, but a reflex is when it's past 180, when you're going the long way around, it's a reflex angle. It's between 180 and 360. All right, so let's look at some examples of what those would look like. An acute angle, that would be an acute angle. A right angle is shown with a box. You put a box in the angle. That shows that it's square, just like the corner of a square. That's 90 degrees, so that's a right angle. An obtuse angle looks like that. It's greater than 90 degrees. A straight angle, that would be a straight angle. And a reflex angle would be this part of the angle that we go the long way around. That's a reflex angle. All right. Let's see here. Okay. I am going to stop there. I want you to have time to take the quiz. So here's what we'll do with the homework. You do have a homework assignment. I'm going to go ahead and assign it even though we're not done with the notes. And if there's any part in the homework that we haven't covered, So, perpendicular lines and things like that, then just skip that, and then we can make it up the next time. Okay, so do what you can of the homework. Everybody understand? All right, and we'll catch up on the notes next time. We're a little bit behind, but we'll get caught up next time.